I don't do that very often, but it's something that I would encourage people to do who want to. So they're trying to use modules to sort of have an object-oriented or a encapsulated approach, and you can create a public table. So what Barry was saying is what I just did there a minute ago. Oops, that's not it. So I created this local public table, and then I would attach functions to this and return public at the end of my file. Ugh, if one could type. Let's not return that. I return public at the end of my file. But what if I wanted to have some like private functions? So everything attached to public is now visible outside of the module. But if you're like a C programmer, or not C, a C++ programmer, you go, I want private. Well, sure. Okay, there you go. Private. Equals. Boom. Add some more functions in here. Use them off of private, but never return it. Never show this to the outside world. So that's a nice way to sort of split things up. I usually do this by having local functions that are forward declared, but this is another perfectly valid way to do it. Let me get this all out of here now before I totally mess it up. All right. All right, we got 15 minutes. I can do it. Boom. Shoot. All right. So anyways, I call move target left to start the ball rolling, and it moves the green dot to the left, and when it gets to the end here, it will call move target right eventually. Dun, 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 and it'll start moving to the right. So now we have a moving target. Now I'm not going to give this thing a body because I don't actually want to hit it. All I want to have is something to aim at. So let's create a turret. First of all, when I say a turret, what I really mean is like a turret base. This circle here, this yellow circle, is going to act as a visual representation of where my gun is, my cannon, whatever you want to call it, my turret. And this blue box is supposed to visually represent the barrel. So it's just to give you this nice, oh, it looks kind of like a gun. My brain can deal with that. It's a gun. It's a weapon of some sort. The way I do that is I say local turret, and I create a circle. I place it in the center of the screen, and 100 pixels below the horizontal or the vertical center of the screen. So right here. I set the fill color to 0000. In other words, I make it invisible. I give it a stroke color of 11, which is yellow. I change the stroke width to 2, so it will clearly show up in our example here. If I made it 1 in the simulator, you may not be able to see it at certain resolutions. So I just want to make sure you can see it clearly. And then I do a little tricky thing. I create a barrel, which I place at the same position as the turret, wherever I just placed it. I make it 20 pixels wide, 50 pixels tall. I also make it transparent, or has no fill. And then I give it a stroke color of 011, which is cyan, sort of off blue, if you like. I give it a stroke width of 2, again, so it shows up clearly. And then I do this little trick. If I didn't do this, what we would have is initially we had this, where the rectangle was centered on the circle. But I want it to look more like a barrel pointing out. So I use the anchor. I use the Y anchor, and I push it down. I basically say anchor it near the bottom of the rectangle, but not all the way at the bottom, so that it semi-overlaps the center. In other words, this would be all the way at the bottom. This is where the bottom of the rectangle is now aligned at the center of the circle, which, you know, that could look kind of okay, but I kind of liked it better where it was more like, I don't know, let's try 75 and see how that looks. 3/4 of the way down. Let's do that correctly. Load it. Yeah, that looks pretty good too. So now it's 3/4 of the way down. So really what we're anchoring is right here on the rectangle. Now the cool thing about this is anchors are really powerful in the sense that although I've sort of offset it, if I rotate it, it's now rotating about this virtual point. This is the center of the object as far as Corona is concerned. So as it rotates, it's rotating about that point. So it gives us this nice visual aesthetic doing exactly what I want it to do, which is rotating and pointing like a barrel. It's my poor man's barrel. Okay, so now into the meat of this. The meat of this, what's going on here is I've added an enter frame listener that is attached to the barrel, and what it does is every frame it says determine a point, a vector between the barrel center and the thing that I'm pointing at, and then rotate the barrel so that it's pointing in the same direction as that object. So to do that, we calculate the vector, and then we convert the vector into an angle, and then we change the rotation of our turret to be the same as that angle. We want our angle to be the same as the angle of the vector. So to do that, it's very simple. We use the Math2D library, and we use the Diff function. Now, diff is like subtraction. It's doing a subtraction, but what it's saying is it's saying subtract. If I had said this, right? This was a change that I made when I released the library to make it a little bit simpler for folks who maybe didn't read the documentation. I didn't want people to see this and assume that I was subtracting. I was doing this. This is what that implies. It's saying, if you read it straightforward, it says do a 2D subtraction, self minus target. That's just what the brain says. Now, to get the vector from here to here, what we really need to do is subtract the position of the turret from the target. It sounds kind of counterintuitive, but once you have understood how vector math works, what we're really trying to determine is the offset between here and here. And so if you think about it, what is the, if it stop moving around, make it a little bit simpler to visualize this. We want to know how far away this is from here, not this from there. So to get a distance, in a sense, it's always where we are to where we were. We want to go from here to here, so we have to subtract this position from this position, and that gives us an arrow, in a sense, pointing in the direction of the target. So long story short, we have a subtraction function in Math2D, and it operates left to right, self minus target. Or if this was argument A and this was argument B, what it's saying is subtract B from A. Just like you would expect for normal subtraction, left to right. However, the operation that we're doing today, which is trying to create a vector pointing from A to B, you do it all the time. This is like the #1 thing you do with vector math for action games and arcade games and stuff like that. You're always doing this. So I thought, why make it confusing? I will simply add another function called diff, which is the difference, which says the result of this is actually target minus self. But in my brain, I'm thinking, what I really want to do is I want to get the vector from self to target. So the vector from self to target is actually the position of target minus the position of self. I just want to be super clear about this, so people, when they do this, and if they try to use subtraction, you're going to get exactly the opposite result. You're going to get, if you did subtraction, you'd get a vector pointing from the target to the turret, which is not what you want. Okay, so given that we now have a vector, which this will return a table containing an x and a y value representing the direction and the distance between the turret and the target. We can simply take that and convert it into an angle by calling Math2D vector to angle, which takes a vector argument and converts it into an angle between 0 and 360 degrees. Well, 360 degrees minus some small number, not inclusive.